introduction and general information about the course. Afterwards, we directly start with our Arduino board, and we would like to introduce you to the Arduino hardware, and afterwards to the development environment, the Arduino IDE, in which we could program own little projects and flash it to our Arduino board. And next, we would do a little application together, as I told you before, with the adjustable resistor, the potentiometer. There we will give you the explanation to the measuring or measurement theory. And afterwards, we show you an example project with the potentiometer. We hope that you are all ready to do it together with you or with us, because in the next lecture we will, or you will, do projects by your own, and we will support you. And therefore it is quite important that you understand everything around the Arduino and the Arduino IDE. Therefore, you are always invited to ask questions. Do not hesitate to ask. My colleague Harry Ott and me, we are always there to answer your questions. Okay. Just give me a second. So now I hope it will work. Okay, then we do it in the other way. Then let's start with a short introduction. Harry, if you would like to have the word, please introduce yourself.
Yeah, thank you, René, for the introduction. Yes, my name is Harry Ott. Yes, I'm studied or get my bachelor degree at the University of Cologne in automotive engineering, with main focus on multi-body systems and optimization algorithm. Yes, after my bachelor degree, I started to work at the University of Cologne as a research associate in many kind of tasks. I'm responsible for require a new research project and for plan and work at this research project. And next to this job, I started my master study in mechatronics with main focus in open loop control system, closed loop control system as well, and and simulation, many kinds of different kind of simulations types, and as well develop multi-body system to develop different kind of control systems. And now last year I get the opportunity to do my PhD study as a cooperation with Uppsala, and there are my research topic is electric propulsion system for electric light vehicle. It's a kind of I would say a cargo bike. This is a bicycle which you can transport different kind of freights, and therefore I will develop a propulsion system which is part of two electric wheels. And therefore I will develop a control system that increase or improve the dynamic stability, and therefore I can increase the safety of this type of vehicle. Yes, that is some words to my person.
Okay, thank you, Harry. My name is René Degen, and I am a research associate here at the Cologne University of Applied Science too. I did, similar to Harry, my master degree in mechatronics here at the Cologne University of Applied Science. And we have the great honor that we are doing a cooperative PhD together with your university, with the Uppsala University. And my PhD topic is the development of a virtual test field for highly automated driving systems. Yes, as you can imagine, we are actually here in Germany, and we're just doing a guest lectureship in your main lecture from Ole Svensson. And we are happy that we have the chance to show you something around the Arduino and how to work with the Arduino and make little projects to measure different kind of sensors with the Arduino. But to our additional background, Harry and me are part of the CAD/CAM Center Cologne. It's a laboratory here at the Cologne University, and it's part of the Faculty of Automotive Systems. The Cologne University of Applied Science was founded in 1971, is one of the biggest universities of applied science here in Germany, with nearly 26,000 students at 5 locations. And we have about 100 different study programs, 2,000 different employees of scientific employees like Harry and me, or technical employees. And our laboratory was founded in 1997. Today we have around 20 employees, and we are strongly connected to the local industry or to international industry, and therefore we are quite application-oriented laboratory. And our main research fields are virtual technologies, everything around virtual reality and virtual product development. Additionally, mechatronics, the field where Harry Ott and me came from. We have different projects around controlled systems, and project like mine, where we do the connection of virtual reality and mechatronics by the development of a virtual test field of highly automated driving systems. And additionally, our last research area is technomathematics, with projects like optimization problems or projects, or everything around artificial intelligence. Yes. Next, we would like to structure or give you a short overview about our 2 lectures, the one today and the one on the 2nd February. Today we just would like to start quite slowly, and would like to give you an introduction to the Arduino and the Arduino development environment. For us it's quite important, or for you it's quite important, to were introduced to the Arduino, and to get used to the Arduino, because next time we will do, or you will do, projects with different sensors by your own. But together we will do the project, I would like to say, for you or together with you. And we have chosen, therefore, the sensor of an adjustable resistor in the frame of the potentiometer. On the next appointment or next lecture, we will do projects with the photodiode, with a temperature sensor, an ultrasonic sensor, and a gyroscope. The complexity of these sensors will increasing from the photodiode to the gyroscope. And therefore we have developed short projects where the specific issues of these different sensors were applied. Do you have here any questions to the general structure of this lecture?
No.
Okay, perfect. The structure is so that we will introduce you first to the to the measurement theory, or to the different physical functionality of these sensors. And afterwards, we will do applications by short projects. Okay, then I think we would like to start with the Arduino itself. In best case, you all have the Arduino in front of you. The Arduino has two different sides, the top view, which you can see on the left-hand side of this page, and the bottom view, which is on the right-hand side of this page. Let's start the introduction on the left hand side of the Arduino board, which is shown on the left side. There you have on top the reset button, which you can use to reset the Arduino itself and the actual program or procedure which is running at the Arduino. Then you have the USB port, which depends of the age of your Arduino in these new ones. I hope you have all these Key Studio kit. There, all the Arduinos has a Type-C interface, but older ones have normal micro USB or something like this. But this is not really important for the functionality of the Arduino. Then you have a switch where you can switch the working value or working voltage of the Arduino from 3.3 volts to 5 volts. This depends on the sensor, and this is quite important for the values you read in or you would like to give out over the Arduino. And additionally, we have the possibility for an external power supply or power interface. This is made for standalone applications. Maybe when you have developed a project and you would like to install it at a mobile system, like a vehicle or something like this, then you not always have the connection to your personal computer. Is there a question?
Yes, regarding the voltage switch.
Yeah.
What output does it change?
It changed the voltage. You have different voltage levels.
But the Arduino already has both 5 volts and 3.3 volts.
Yeah, you're right. But you have the different analog and digital inputs, and the working value or the working voltage of the Arduino depends on the position of the switch.
Okay. So it's the reference for the analog ports, or?
Yeah. That's
okay.
That's correct. But you have you will see later on that you have different other power input or output ports, which you can see on the lower side of the Arduino. There you can directly address 3.3 or 5 volts at the Arduino kit. Okay. Thank you. Yeah, and additionally, we have on the lower side of the Arduino 3 big parts. We have analog ports on the left-hand side, the A7 and A6. And on the complete right-hand side, A0 to A5, these are the 8 analog ports of the Arduino. And additionally, we have, as mentioned before, power input and power output ports from which we could read out, or it could be used for power supply of maybe a motor or something like this. Okay, on the right-hand side of the Arduino, there is a direct connection from the analog ports A0 to A5. The difference between these both ports is that the lower ones have a female interface, and the upper parts have a male interface for connections. Then we have ICSP ports it's an additional form of programming the Arduino when there is a reason why you could not use the USB port. Then you could use the IC/SP port to flash the Arduino with your program. Above we have the serial communication interface, and then above the serial communication interface we have PWM ports, which we will not use in the frame of this lecture. Yeah. And on the top of the Arduino we have the 14 digital ports and the I2C communication interface, and the left and right ports which were signed there are the serial clock and the serial data. These ports are quite important for the structure of the I2C communication.
Maybe here one addition. In the last sensor, we will use a gyroscope. We will use the E2C communication interface, but we don't have the time to explain the detailed theoretical part of this protocol. So we will use in a library where we have a special function that we can use this interface to read this sensor for some information right now.
Perfect. Yeah, if you have any questions to the specification of the Arduino, then you are invited to ask them now. Additionally, we have linked the data sheet and the web page of KeyStudio on the link below. There are quite every information or all information about the specification of the Arduino. I think we have not explained every part of the Arduino, but the explained ones are the ports or devices or parts of the Arduino we will use in the frame of our projects. Perfect. Then let's have a look into the general specification of the Arduino. As we told before, the working voltage of the Arduino is between 5 volts or 3.3 volts. It depends on the switch position. The external power can go from 6 to 15 volts. From the supplier, it is recommended to use 9 volts. The digital I/O pins, we have 14 of them. Then we have some of them have the PWM functionality. They are shown by this little sign on the right-hand side. I'm not pretty sure if you can see my mouse, but this is the sign how the PWM ports are signed. Additionally, we have an analog input channel. We have 8 of them, A0 to A7. The DC current from the I/O pins are 20 milliamperes, and the DC currents for the 3.3 voltage pins are 50 milliamperes. We have an internal flash memory with 32 kilobytes and clock speed of 16 millihertz. I think there's a cool question. Do you have any idea why this clock speed is that important for every program with the Arduino? Do anyone has experience with the Arduino? Okay.
It sets the reference for PWM and such. You can have a maximum. You can use the clocks directly for high speed applications like PWM dimming or.
You're definitely right. The clock speed is our minimum time for the for one step of the Arduino. In the program, you can imagine it like it's the time for at least for one row of the program code of the Arduino. Our shortest time step which we can use in every operation of the Arduino. Perfect. And then additionally, we have an onboard LED, which is addressed by D13. Yeah. Additionally, we have different communication protocols of the Arduino. We have the serial communication interface, the PWM interface, external interrupt interface, the SPI communication interface, and the I2C communication port. Do any one of you have an imagine how the interrupt is working in the frame of a program? Okay, an interrupt is a possibility to interrupt a running program code. In a normal way, you have a loop function where the program code is always continuing. Yeah, when the from first line to the end line, and then you start it until anything will interrupt it. And here you have the possibility to address different ports. And when you have initialized them, then external devices could interrupt this running procedure and yeah, makes it hold on this specific row and maybe do a specific or other interaction or operation which will not be done when the Arduino is running the normal way. Perfect. Then I think the main specifications around the Arduino hardware were done. Do any one of you have a specific question to the Arduino or to the hardware or to a communication protocol or something like this? If not, then I think it's good to start with the software part of the Arduino. Or there is a software which is named Arduino IDE. IDE stands for Integrated Development of the Arduino. I'm not pretty sure, do every one of you have already installed the Arduino IDE? Yeah, just give a thumbs up or something like this if you have already installed it. If not, you should do it by yourself till the next lecture, because then we will need it to work with the Arduino. In best case, you have already installed it now, or maybe you can do it in the break time. Then you could directly do our program together with us, or the project together with us. Okay, the Arduino IDE has one main task. Yeah, it's, to say it in a short way or simplified, it's the complete communication between the Arduino, between your computer and the Arduino. And it will flash your developed code to the Arduino board. There, the Arduino IDE will support you on different stages of your program code. You have these different icons in the toolbar. On the left, when we start on the left-hand side, you have the verification button, which verifies your code. And when there are any mistakes or syntactical failures, it will give you a feedback. Then you have the possibility to upload the code to the Arduino board. Then you could create a new project, could open an existing project, and you could save the actual state of your project. And on the right-hand side of the Arduino IDE, you have a serial monitor, which could be used to show or to overview the communication ports of the Arduino to a sensor or to anything else. Okay, perfect. Then here you can see an complete screenshot from the Arduino IDE interface with an example which we have done before. There you have the different main parts of the Arduino IDE, the menu bar, which is above the already explained toolbar. And the menu bar, there are, I think, the important one is the tools button, which will be introduced later on. Then we have the text editor, at which point we will fill in our program code. And on the bottom of the window, we have the user board and the COM port, which means there you can see your specific Arduino hardware, and you can see which communication port is actually initialized. Yeah, and this Arduino IDE has the side tasks, we will call it side tasks, of formatting, of format, of syntax, of compiling, of linking, and of debugging. Simplified, the Arduino IDE will support you in the complete process of developing any projects with the Arduino. And you don't have to do everything by yourself. You just have to fulfill or fill in correct code, and the linking of the port and of your sensors, etc., will be done by the automatical linker of the Arduino if you have initialized the correct ports in your code. Okay. Do we have any question to the Arduino IDE itself? I think later on we will go to a practical application, and then you will get started or introduced to the IDE yourself. But when you have here any questions, feel free to ask. Okay. Okay, then let's go further. Yes, this is an quite, I would like to say, not complex, but an yeah, example code from us, and we will recommend to you to use the following programming syntax. First part is a header file. I think header files are not important. They're not important for the functionality of the code, but they are important for any part of co-working or for when you would like to apply the code in 2 years later or something like this. There in these comments, you have the possibility to describe the functionality of the code itself, to give some information about you and who was the developer of the code. And additionally, you could declare their inputs and outputs, which will be useful when the code is quite longer than this example. When you have 2,000 rows of code, then it could be quite good if you have described there the input and output variables or parameters. Okay, the next field is the real start of program code, the parameterization field, where you could set different parameters which you will use in the frame of your program code. Then afterwards you have the possibility to initialize ports or something like this. In this example, we would initialize the LED port. And yeah, then the last part of this programming syntax is the real programming code, the loop function, where you have the possibility, or where you have to fill in your code and your functionality in the correct way. And in the frame of this loop, you could address the parameters you set before and the pins or something like this you have initialized before. Yes. Additionally, we have two fields. One field is the message field, where the information about the exchange with the Arduino will come, and the console field. Yes, this is showing the output text of the Arduino, and we'll give you other information, for example, from the memory, the flash memory, or yeah, something like this. Okay. Are there still any questions to the general structuring of program code? I'm not pretty sure if there is anyone. When there is anyone, please.
René, can you please zoom in this yeah, in this code, because it's not so good to read. Yes, thank you. It's better now.
But I think it's not important to know the code yet. It's just a simple example. The main thing of this page is the structure of the programming code. Okay, when there are no questions, I think we will go further with the serial communication. As we told before, you have in the menu bar the opportunity to address the serial communication interfaces of the Arduino. And here you have the possibility to do it in two different ways. The first way is to have something like a serial plotter. It's quite next to an oscilloscope or something like this. On the left-hand side, you have your parameter you would address about the COM port, the communication port, and on the lower axis you have the timestamp. It's not really a timestamp. It is separated into the Arduino steps. This means every step where the Arduino addresses the COM port to read out the actual value. And on the right-hand side, you have the serial monitor. There is no plot or something like this. The serial monitor gives you the possibility to interact with the Arduino. In the input field, you could give orders or new parameterization of your variables. And then you have on the lower side a timestamp, and on the lower right-hand side the baud rate, which means the transmission speed of the Arduino. It means the speed, how fast the Arduino goes to one procedure, how long it takes for one operation, one code procedure. Okay, are there still any questions to the serial plotter or the serial monitor. I think you will get introduced to them a little bit more practical in the frame of the different projects. Then we have made a short video in which the complete Arduino IDE is explained step by step. Yeah, it's not just the different views of the Arduino IDE. It is the complete process from from the Arduino to initialize it with your computer, then the complete start of the Arduino IDE, and which buttons or parameterizations you have to do to start with this specific Arduino board you have connected to your computer. Yes, this is for you for reviewing at home. And when you have some other questions to the serial communications or the Arduino IDE, Harry and me will be there to answer these questions. I'm not pretty sure. This is the Arduino Uno Plus board. I think this is the board you already have at home, or we hope that you have the same one. If not, it's not really a problem, because in most of the Arduinos, or all our Arduinos, work in the same way, but it depends on the model. They have different interfaces and different analog or digital inputs. But yeah, they all work in the same way. Okay, then for our later on projects, we have some short general code parts to use for in the Arduino programs. It begins with a serial begin. This initializes the board communication. Then you have the serial print in, which is to print in data to a serial port or something like this. And you have the initial. We have the different pin modes where you could switch from pin mode input or output, and then you have analog read, digital read, analog write, and digital write. These orders you have to use to address the different pins and give them different values or read out the values of the different pins. And last but not least, we have a delay function, which is useful to have a delay in the program code. This is useful when you sometimes have a sensor which is not that fast. It's not that fast how your program code. Then you sometimes need a delay to wait for the new value of the sensor. Yes. But these are just some examples of code parts for the Arduino. We have linked you a page with further informations and further code parts below. But for our projects we will do in the frame of our 2 lectures, we just need, I think we just need these code parts or these orders. Okay. Then I think it is a good time for a short break. before we start with the general measurement principle or the measurement theory of the potentiometer. Yeah, if you would like to have a short break, then we will see us in 10 minutes. Is it okay?
Yes.
Yes, one addition, when you don't have installed the Arduino IDE before, so you can maybe use this break to install it, because later when I'm programming in front of you, you can copy it and yes, doing your first own experience. So try to use this break to install the IDE if you doesn't do it before.
I have a question. The video you had before, I can't find it anywhere. Where are you supposed to find it?
We have uploaded the complete pages in the how to say, in the course program for today's appointment. I have uploaded it just before the lecture. You can look into the Uppsala page. I'm not pretty sure how it is called. I think Canvas or something like this. And there you could download the pages of our today's lecture.
I found the PowerPoint. I didn't find the video. It's just the picture on the PowerPoint.
If you have Adobe, the Adobe player, then it has to be a video. But I can control it, and
I'll
then
check.
I will upload the PowerPoint.
I'll download it. Try.
Okay. Perfect. Then we will see us again in 10 minutes.
Potentiometers, or pots, as well as trimmers and rheostats, are frequently confused as they're very similar. But don't stress about it too much. People know what you're talking about most of the time, though more precision are frequently confused as they're very similar. But don't stress about it too much. People
yeah, with a short video. Additionally, this view will help to understand how this adjustable resistor is working. As you can see in the middle drawing, you have these 3 pins again: ground, 5-volt, and analog pin. And it depends on the specification of the potentiometer, how the value of the resistance is. The most resistance you have always between ground and 5 volts, or the operating value pin. This is always the full resistance of the specification. And it depends on the position of the slider. With the slider, you can switch the analog port or analog pin position. And by this, you can switch the resistance, or the resistance between, for example, ground and analog pin, or 5 voltage and analog pin. When you can see my mouse, it is always when you, for example, switch the analog pin to the maximum, to this maximum level here, then the voltage between or the potential between the 5-volt pin and the analog pin is the minimum. It's not always 0 ohms, but it's nearly 0 ohms. And when you change the position, then the ohm number increases. The same way when you do it from ground to the analog pin. And the resistor material, it depends on the resistor material in the middle, how the resistance is changing. In most cases, or in most cases, you have a linear changing of the value from the resistance, as you can see on the right-hand side in this diagram. But there is a possibility when the resistor material for example, change this diameter, the diameter of the wire, then it could be an maybe logarithmic changing of the resistance. Yes. How it mechanically will work? There is a small grinder which slides on the resistance wire, on the wire, and when you change the slider position, the grinder or the connection to this resistor material is changing. But for a better understanding, you could just look at the video, and there it will be shown in a short video. Perfect. Yes, when you have understand the theoretical functionality of the or the physical functionality of the potentiometer, we have another problem, or we have a little problem in our measurement world. In the real world, we have no defined number of values between two numbers. In the analog way, or on the Arduino, you have a different, you have a specific steps or digital values. For example, between our 0 voltage and our operating value, we have always 1024 different digital values which separate our sensor value. For example, here you have when you have 5 voltage as operating value, then you have 5 voltage divided by 1024 units. This means every step, every digital value have a step size of 4.9 millivolts. An easy example, when you have a digital value of 123, it means that you have a voltage of 0.6 volts. I hope that you have understand the separation or this difference between real world and the analog world of the Arduino. The number of digital values always depends on the way of flash memory, or on the how many registers and how many space is at your flash memory, how many values could be or how the value could be separated into different digital values. Do you have any question to this art of separation, or this specific way of working with digital values? If not, then we will switch to some applications for potentiometers. I think an application everyone of us knows is the picture on the left-hand side. There is the possibility to change the music, or at your music device. It's always, or in most cases, done by a potentiometer. Additionally, we have application on a lifting system, where the position of the lifting system is measured or determined by a potentiometer. In this case, the potentiometer slider is connected to a wire, which value changes when the lifting system changes its position. And another traditional application is the measurement of angles from any rotating system, maybe a electric motor or something like this. But there's a big amount of different systems which use potentiometers, and they are all available in different forms and accuracies. This means that it not always has to be a grinder which changes the value of the resistance or the resistor. It just could be other forms of by which the resistance is changed. Okay, then the theoretical part of our lecture is nearly done. I hope you have understand how an Arduino and how the potentiometer are working. And if you have no question to the general functionality of the Arduino or the potentiometer, then Harry will introduce you to the program itself and the Arduino itself by doing a short project with the potentiometer. And you all were invited to do it by yourself at home. And when you have any problems or it is too fast how Harry is working, then please give us a short sign that we can stop and you could come with. Perfect. But are there any questions to general functionality or something like this?
So yes, thank you, René. Maybe you can get to me the rights to share my monitor.
I think you have already the rights.
No.
I have to stop my one.
Maybe now I'll try. Yes, so I hope you can see my screen. So yes, first of all, we will connect our potentiometer, which is yes implemented on a shield to the Arduino. Therefore, we will connect as a power supply. We will use 5 volt. So please connect it to the 5 volts. And yes, ground it is clear, and we will use to read the analog value. We will use the analog pin A0. So maybe I can show you how I connected it. So yes, and when we have done it, we first open the Arduino IDE. So I hope you can see that it's right now is opening the IDE. Yes, so now the IDE is open, and we will see that we already have the main functions, the void up setup and the void loop function. First of all, how we said, it is necessary to have.
We can't see your ID.
Oh, sorry. Okay, it's. You can see it right now?
Yeah.
Okay, sorry for that. So here we see when you open the Arduino, it's automatically create a sketch for you. And you see there are the main function, the void setup function and the void loop. There are already a comment. I like it when the comment is over the function, though, so I change it. Yes. So the first part is to make a text or a comment for the main sketch, what we will do, and give them give them a title and so on. This I will do in form of a commenter in this way. So if you are writing a backslash operator with a starlet and you see that you can write a comment over many rows. So for example, we called it poti read And what we will done is the task is the potentiometer value will be printed in the serial dialog. So now we can take the datum when we created. So this is created on 21st January. And sometimes when you do some modification later, it is necessary to write down what you are changed. So you can take this commenter for some modification, modified on. I will do it create on. So because we don't have changed it yet, we don't pull some take some comments. So now we can start with the programming. So after the comments, we first needs the initialization part or initialization field. So initialization of variables. And now we declare or allocate a variable. We will call it voltage, and therefore we will use a data type integer. The command therefore is int, and we call it first variable. No, we call it voltage. It's better. So it is every time important to make a semicolon to show the compiler later that this row is finished. So therefore we need additional comment what kind of parameter we have. So we called it potentiometer at A0. If you do a comment only over one row, you can use a double backslash. This show the compiler later that this is doesn't to be compiled and flashed to the Arduino. So now we have initialization of one variable. So after that, we can start setups. So later we want to show the value to the serial monitor. So we have to initialize the serial communication. Therefore, we use the command serial begin. Serial.begin. So you can see that the color is changing to orange. That means the IDE is allocate this function, and we set up the baud rate to 9,600. And after that, we to check if the later the serial communication is already or done, we can start to print something. For example, we print serial print ln. So we need round brackets, and now we send a string. For example, Uno or Arduino is ready. So we can see later that that's a serial communication interface get this get this string. So now I forget some comments, some important comments. Start the serial communication. Print. Oh, sorry. So print the string Arduino is ready. So after that, we have finished our setup. We need only the setup for the communication. And now we start our void loop. So this function is running all the whole time. We flash the code to the Arduino. Now we need or we have to allocate the value we want to read. So we use now the function analog read, and we want to read the analog pin A0. But we want to allocate this value to the variable voltage. So therefore we use the voltage is equal to analog read. So we get this value to voltage, and now we want to print this value to the serial communication interface. Therefore, we use the function serial print L as well. We done it before. So serial print ln, open the roundy brackets, and write down our variable voltage. So now we finished this row, and I've already forget some comments. So therefore we write down read the ADC value and print the ADC value to serial communication interface. So after that, or finally, we take a short delay. So therefore we use the delay function. We already show you the function. So therefore we use delay and type in 5, because this function or the argument 5 means that we make a delay of 5 microseconds. So now we we have done our first, I would say own code. So next we can connect the Arduino to our PC due the cable, USB cable. After we have done, you can on the bottom right side, you see that there are recognized that the Arduino is connected on our communication port 6. And now, we can check if we don't make any mistakes. So therefore, we click the button verification. Now you can see the Arduino IDE is compiling the sketch. And now, okay, it's good. There's a mistake, and normally on the bottom of this error message, you can see where it could be or where your mistake can be. Here you can see that we forget a semicolon, and this is the reason why the compiler don't know where is the end of this programming row. So now we have fixed our fault, so we can check now, and we will see that there's no error anymore. So compiling is done, and how the colleague René has said before, you see in this black box some further information. So, for example, here our sketch is used 6% of our programming storage. So here you can see that the Arduino is a very small microcontroller with not so much power. You get very fast the whole storage. And for the global variables, we use 206 bytes. This is our 10% of the dynamic memories. So now we have checked, we have connect the potentiometer, and we have connect the Arduino, and we have verified, so we can upload this code to the Arduino by clicking the button upload. Yeah, we can see the command that he's uploading now, and now the uploading is done. So now we will check if we can read the potentiometer value by using the serial communication interface. There are two options to get this interface. You can go to Tools. Here you can see the serial monitor and the serial plotter. But the serial motor you can as well use by clicking this button here. So we click serial, and now we see, okay, he's plotting the values each 5 microseconds. So now I'm switching the stick around, and you see, okay, the value is changing.
We can't see it.
You can't. Oh, it's with my wait. I have to share my whole PC. Do you see it right now?
No.
And right now?
No, I think you have to share the complete screen and not just the page.
Okay. First I stop my share. So maybe you can see it right now. So yes.
Yes. Now
I think okay. So now we can see this interface, this serial communication interface, and I'm changing the potentiometer value by turn around this stick. This is the maximum value 1024 because we have our ADC has a 10 bits resolution, and the smallest one is 0. And yes, so maybe I show this plot by the serial plotter. Okay, I have to close the serial plotter. So I show you the time plot serial plotter now. You can see here we have choose serial the baud rate. When it doesn't work, you have to check if you have here the same baud rate you are at the beginning of the code. You have to find. So 9600 is the right one. And now I am changing the value, and you can see how it's changing, and it runs how we have defined it. Do you have any questions before I give you some other, I would say tips or some other kind of programming things?
I sent a question in the chat.
Okay.
He has asked why specific 9600 in the serial begin, why the baud rate is 9600.
This is a standard value. You can change, for example, you can change this value, or I will do it.
In specification, it means that per exchange, 9600 signs per message were transmitted. You know what I mean? It's the length or the specification of each message. In this case, we have 9600 different signs per message.
Okay. Yeah.
And It's a standard value for Arduino applications.
Yes, and this is how, the serial communication. So yes, they need the same value to interpret their flags when I send the digital flags, and the other one has a different kind of baud rate. He can't interpret your values he's sending to the serial communication interface.
Harry, another question was why you use print in and not just print, the order print in.
Print in, oh sorry, print in or L, this is, it means the interface this is a bidirectional interface, so you can't send information to the serial communication interface, but you can send from the serial monitor, for example, some strings to Arduino. So, for example, here we can write down hello, and he sent it to the Arduino, but I don't have here a code that is receiving this information. So this will be done the next time. I will show how you can communicate with this interface through different kind of strings.
Could you explain what the Y value means in serial plotter?
Pardon me?
In the serial plotter.
Yes.
Could you explain what the Y-axis means? Is it the
Y? Sorry.
The Y-axis in serial plotter, not in
the serial plotter. Okay. Serial plotter. The Y-axis is. Oh, sorry. Yes, the Y-axis is the. It's the ADC value. So now the ADC value is 0, and here we get the maximum. It's 1024. 23. Sorry. But this is not our task. We want to get the voltage. So we have done some further programming task. So for example, here we can change or we have to do some calculation. So we have get here the voltage, but this is not the voltage, it's the ADC value.
Just stop. Do everyone has understand what Harry said? Or what he has done? We just read out the actual state of our potentiometer by now. And to get a voltage from the different potentiometer position, you have to do a determination in the frame of the code. It depends on the step size, which we have declared before. When you don't know how high is your step size is, or which value your step size is, then you could do nothing with this digital value of 1000 or 900.
So yes, we have only read the ADC value, and this ADC value we have to calculate to an voltage value. And therefore, we have to done some calculation. The René has already shown in, I don't know which kind of page, but we have done the calculation. We have to multiply the ADC value with 5 volt and divided it to the resolution of the ADC value. So the resolution is 10 bits, and so therefore we have to divide it by the value 1023. So I will show you it right now. So we change this voltage to the name, or we add another value. We call this ADC value. So now we read here the analog value and allocate it not to the voltage. So we allocate it to the ADC value. And now we make a calculation and allocated it to the voltage. variable. So therefore, we use a calculation. So we multiply the ADC value with 5 for 5 volts, and then we divide it by the value 1023. So, and then we allocate it to the voltage and print this voltage value. So now we have to verify that and checking if everything is all right. So it does. So now we can upload this new code to the Arduino, and now we look at the serial plot. Now we see that we get the value of the voltage value. So if I'm changing or turning on the stick, you can see the voltage is changing. But the problem here is that we have a resolution of 10 bits, but we have done, I would say, we have done some mistakes. We have chosen the wrong data type for this voltage. So we use integer, and so we are not able to plot floating points or points or numbers with decimal digits. So now, therefore, we have to do some changes. So first of all, we use another data type. So we use a double. This is data type for floating point. So, sorry, not the ADC values. The ADC value is an integer, but the voltage is now a double. And if we are doing here the calculation for the voltage, we have to do a typecast. This is a very specific informatic, or a typecast is we use here the ADC value is an integer value, so we can don't allocate integer value to the voltage value. So we have to do a typecast. This we can do by writing here the
E.
Oops.
Yes.
Okay, so by writing the double before our calculation, and now we can get a better resolution of our variable voltage.
Can you now show the plot? Harry? We can't hear you actually.
My Zoom is always muting me. So now we have changed. We have verified our code, and now we uploaded it to the Arduino.
Could you explain what double did again? What it means? I didn't get it.
The typecast here.
Yeah, just double. What does it do?
Double integer. That's our data type. So when you are programming, you define or allocate variables. You have decide before. We have decide before what kind of data type it is. So the ADC value, it can only be integer value. So therefore, we define it as an integer. So you can't get you can't you can't use here how can it say it values with decimal digits. But we want the voltage not only 1 volt or 2 volt or 3 volt. So we want some decimal digits, and therefore we have to use the data type double. So double is give us the opportunity to interpret this variable as a decimal digit value or number. So I will, yes.
This means integer just have full numbers, and double could show numbers which have numbers after the dot. 1.5, 1.6, 1.7, and the integer values just can show the full numbers, and therefore we have a bigger separation of the different values between 1 and 5, 0 and 5 volts.
Yes, of course. So now we can see the results. Now we have 5 volts, and I'm changing the value, or I'm turning on the stick, and you can see that we have a better resolution.
Can you go to 1 maximum and then just
okay,
go
this
one?
Is, okay,
one
this
step?
is this. Yeah, it's very difficult to go by step. So I'm trying. So it's not possible here.
Okay.
I mean, this is one step. So we increase decrease. So
when we decrease the level,
yeah,
the resistance.
But there's another special trick. Maybe I can show it as well. If you said that, okay, this resolution is enough for my application, you don't change it. But for example, if you say, okay, I need a little bit more or a better resolution, you can do a very simple trick. You can compute it or calculate it in millivolts. So I add only I change the 5 volt value to 5,000 millivolts and divide it by the same value. Now I can upload it, and we will see that we get a little bit better resolution. Now I'm trying to do only one step. It's not possible.
Quite difficult.
Yeah. Now you can see, okay, it's a little bit switching, but you can see the value 4.89. This is the minimum resolution we have. So when you use your calculator and compute 5,000 divided by the value 1023, you get this value. So this is the smallest quantization value we can show.
This is not completely right. We have 1024 digital values. You have divided it through 1023. We have one step more. Then we have the exactly 4.9 millivolts.
Of course, yes. This is here. You can I show you the calculation we have done here. So we have 5 volts as an input. We have causes by the ADC resolution of 10 bits. We have 1024 values or units, and when you divide it, we get the value 5.9 millivolts per digital value. And now we can see that this is the value when I'm trying to go only one step or one ADC value.
Perfect.
Yes. Yeah.
Question.
Yes.
In the code, when you say delay 5,
yes.
Did you say that was microseconds or milliseconds?
Sorry, it's milliseconds. Sorry.
It's milliseconds. All right.
Yes.
Thank you.
So, for example, this we doesn't change, so we can show it one times. So we make a delay of 500 milliseconds, so in a half second, and then we get the value every half second, and here we can see the performance of read out the value now right now.
But exactly, you have to add the clock time too. The delay is just how long the Arduino stays at this specific line. Additionally, the Arduino needs for each row one time the clock time. I hope you know what I mean. I think it was 16 megahertz. The delay function is your computer is low. Okay.
Yes.
And yeah, it is a nice trick to change the resolution value or the resolution time of the Arduino, because the rest of the code is going quite fast. But when you have 2000 rows, then you will see that it just not only take 500 milliseconds.
I can try it. I commented out the function delay and boot it to the Arduino and show you what happened. Just so fast you can't. Yes, it's a common rule that you, after you read out or print something, that you take a short break in kind of some milli or microseconds.
Perfect. Then I think we're nearly at the end of our lecture. Harry, do you have anything else for them to know?
Right now, no.
Okay. Then I hope that you have understand the most things we have explained to you. I hope it was good easy to understand, and we will please you definitely to install the Arduino IDE for the next time, because next time you have to you additionally have to upload your own solutions. Then we will give you no code solution by ourselves. You have to do it in the frame of the lecture by yourself. You will become 3 tasks, and after the lecture you have to upload it by your own to Canvas.
Can we get the tasks before?
No.
No. Okay.
You will get it in the frame of the lecture. I think we can be honest. I will upload the pages. I think on Friday, and the specific tasks were included to the lecture pages. When you, if you would like to, you can try to do the tasks before.
Okay. That's yeah. I'd rather do them before, but okay. Thanks.
Cool. Okay. I think it will help you when you just try to start and work a little bit with the Arduino, and maybe when you have not finished the little program today, then you could do it at home. Additionally, you can do a little project which is an additional standard project. The Arduino has a LED at the board. If you would like to, you can do a little blinky code. But therefore, I think you have to do some PWM modulation. Is it right, Harry?
Yes.
Okay.
You can do it by the pulse width modulation, but you can only write a digital yes on and off by write a digital pin on high and low, and so you can see how the LEDs toggle. And this is a good preparation for the next lesson to get familiar with the IDE, with the Arduino, and so on. And yes, and there are so many other simple examples in the internet where you can use to get familiar with the Arduino.
Okay, but what would be nice before we close the lecture would be nice if you can give us a short feedback of this content was too easy or too hard for you. We are not pretty know which kind of knowledge do you already have. Do you have already programmed with the Arduino or with other sensors? Easy and yeah. Can some of you give us a short feedback? Maybe.
Well, we did some Arduino in the first year, but at least I felt I didn't quite get it then because I had never programmed before. Now, though, I've gone through a couple of programming courses, so I understand more of the programming, though I'm still not very familiar with Arduino.
Okay, but do you have fulfilled the program code we have shown you?
Yes.
And your program is working?
Yes.
Perfect.
And I get all the values you spoke of.
Cool, that's perfect. Good, but we will always help you with the other projects, therefore you not has to be scared. But it will be easier when you quite used to the Arduino itself. Okay, then I would like to say we are at the end of our today's lecture. It was nice with you. It was quite, I hope you have fun and you have learned something about the Arduino and the adjustable resistor. And then we will see you the next time at the 2nd of February. Okay. Then have a nice day. Bye-bye.
Bye.
Thank you for today. Bye.
Thank you. Goodbye. Abba,